Hey, so I recorded my whole portfolio thing, and then literally 4 seconds into the video, my audio cuts out. So instead of refilming it because I don't wanna, I am voicing it over. Sorry in advance.
Alright, don't mind as I'm flipping.
Hang on, I just realized I didn't have my desktop audio muted. Alright, so I'm trying to hook up the mic, and I'm like, hey, so this is for portfolio one, standard one. You know what? I'm just gonna pause this. This is for portfolio one, standard one. Standard one basically says like I can integrate and I know what that means. Um, and so part of the portfolio is to combine this with one of your hobbies. So I decided to do that with one of the video games I play, Portal. Um, so the premise of Portal is that it's first person and you have two guns, they shoot two portals. And if you go in one portal, you come out the other portal. And it's important to note here that all energy, movement, any of that is conserved. So, like, you don't lose speed going from one portal to another. So, let's talk about the actual problem. Here we go. So, the problem I set up for us is that you are standing on a tower and you want to get to the other tower. Hang on, I'm about to point. There we go. You want to get to that tower, but you can't just go down and walk because I said so. So what are you gonna do? Well, let's think about it. This is Portal. I don't know why I just looked so viciously at the camera, but like, what can I do to get myself over there? Spoiler alert, you jump. Hang on. You jump off of your tower into the portal and you get shot out the other portal. And then what I was pointing at is that it's a distance of 20 meters. Now, I feel the need to say that I don't know what 20 meters looks like. Someone tells me to picture 20 meters, like genuinely, I have no idea what that is. So, this is my project. I get to pick the numbers, and if they don't make sense, whatever. I say so. You'll see the same thing when I pick an amount of time it takes for us to fall. If it doesn't make logical sense, ignore it, okay? Anyway, so what do we need to figure out how you're gonna be zooming out of that second portal? Well, we need to figure out the speed at which you're going to fall into the first portal. I'm gonna give myself a second here till I point at the equation, and then we'll be on the same page. There we go. So your velocity is equal to the force of gravity times the amount of time it takes you to fall. So your velocity will be equal to 9.8 meters per second squared. It's the force of gravity times 2 seconds. I just decided 2 seconds was how long it took you to fall into the portal. So you get a velocity of 19.6 meters per second. And an important thing to do in math is to pay attention to if your units make sense. So you can see here that it does. You take meters per second squared, which is a known acceleration, which are the known units for acceleration, and then you multiply it by seconds, which, like, we know seconds. You get meters per second, which is velocity. I think I'm saying here that things might not make sense. Oh, also I need to point out that I don't use air resistance. I'm assuming air resistance doesn't exist, and I think that might be what I'm saying right now. So just like, please, please don't call me out on it, okay? I don't want to do that level of physics. I'm not a physics major. But anyway, you jump in the portal, and when you go into the blue portal, you're going 19.6 meters per second. Everything's conserved, so that means we're going out of the other portal also at 19.6 meters per second. So I'm like, hey, well, what can I do with this information? Well, if you give me just 1 second, you'll see that I plug it into this equation. Yep, velocity is equal to distance over time. So we have our velocity, we have our distance that I made up. So then we can solve for the amount of time it takes us to go that distance. Once again, look at the units, it makes sense. So we get a time of 1.02 seconds. Later I round this to 1 second. Once again, please don't call me out on any of my lazy math, okay? This was like my 6th take recording it. I was over it. And now I'm voice recording it. This is my 3rd voice recording attempt. Anyway, I ended up taking all this information, I put it into a nice graph that you'll see up in the corner here. So I basically just took that v equals x over t and I plugged in different times with our known velocity, and that's how I got the points. So, yep, I'm just going to point at the graph for a bit. So on our y-axis, excuse me, on our y-axis we have meters. Sorry. On our x-axis we have seconds. And that's going to be important in just a second here. Whoa. What? Actually, I skipped all the way to the end. What the heck? What just happened? I'm sorry, technical difficulties or something? What, what just... What? I don't know what just happened to my video. Why did it become 1 second? Hope if I do this right, then this should pause the recording. Alright. Sorry about that. Don't know what happened. Also, changing scenery. I had to plug my laptop in. I apologize. But I think we should be back in relatively the same spot. So here I'm talking about what can we do with this? So I mentioned the axes earlier. So let's think about our slope. So we know that slope is the change in rise over change in run, or the change in y-axis over the change in x-axis, which in this case is the change in meters per change in second. Now, does that sound familiar to you? Does that sound familiar? Hang on. I'm trying to do this so we can say this in sync. Oh my gosh, why am I taking forever to get to my point? Bro, what I'm trying to get at is its velocity. There we go. Yep, its velocity. That's why it looks familiar. So your slope is your velocity. We know this. This makes sense. Because if you took the derivative of the function, you get the velocity, which if you take the derivative, you get the slope. So that's cool and all. So I went and I took this information, I plugged it into... Whoa. Hang on. You can't even see right now. Come on, video me, realize. Yeah, no, fix it. There you go. Anyway, I plugged this into point slope form, and I ended up getting an equation for the line, which is 19.6x plus 0.4. Cool. So then what can I do with this? Well, come on. Sorry, I'm trying to be relatively on the same page as video me, but I'm really bad at it. So if you take the first derivative, you get 19.6, which is our velocity. I already said this, video me's a little bit behind, but that's okay. But you can actually take the second derivative of it, and that will tell you the acceleration. So think about it. If you take velocity, and then when you take the derivative, that means you're talking about the velocity in respect to something. Here we're taking it in respect to time. So change in velocity with respect to time, that's acceleration. That's like the definition of acceleration. So we have an acceleration of 0. And let's think about if this makes sense. I already said that I really hate air resistance, and so I'm not thinking about it. So nothing is going to slow us down. So therefore, it makes sense that we have an acceleration of 0. Our speed doesn't change. But anyway, here I'm explaining that, like, because our acceleration is 0, that means that technically you'd keep flying forever and ever and ever until, like, you hit a wall or something. Let's skip ahead, shall we? Anyway, this whole standard is about, like, I can integrate, but I haven't done that yet. So let's do it. There we go. So if I take the integral of f of x, which is my 19.6x plus 0.4, I end up getting 19.6 over 2x squared plus 0.4x plus c. So plus c accounts for any constant that we might have had, because when you take the derivative of a constant, it equals 0. So let's solve for c. When we solve for c, you just plug in your known points so that the only variable you have left is c. You can see that I did this. I plugged 20 in for y, and I plugged 1 in for x. I'm walking over to the other side of the board to show you where I got these points from. Also, if you look at the graph, you go to the x of 1, and then you see you have a y of 20. Here I'm saying, like, yeah, technically it's 1.02, but we're not talking about that. So we get that c equals 9.8. So then, when we put it all together into one big equation, we get that capital F of x equals 19.6 over 2x squared plus 0.4x plus 9.8. And so that is that what that function is that is the position. That is our function of position. So you can see if you like plugged 1 into that, and you like after 1 second, how far did I go? You'll get roughly 20 meters, because I rounded some stuff, so it probably won't be exact, but you'll get roughly 20 meters. And so that explains how we got there. Anyway, I'm done with video me. I think I just vaguely pointed at things after this. I can integrate, and I know what it means. Also, context of my hobbies. I play video game, I play Portal. This has been a video to make. I think this is like my 10th try making it in total, like counting my voiceovers. So, thank you for watching. I'm really sorry for how clunky it was. I'm sure I made a ton of jokes in the video version that, didn't transfer over because I can't read my own lips. Thank you for watching. I apologize for this experience, and bye.